Hello everyone, my name is Ishika Paliwal and I am the student of IIPHGAVV, and today in this video I'll be presenting the solutions of test 1 of information security subject. And so let's dive into the questions. Okay, so the question number first is, there are three basic approaches of authentication of a user, a unique characteristics of a person such as voice and fingerprints, an item that person has, such as machine readable badges, keys, a procedure that the person knows, such as password. If the password is increased in length, it is more secure against the threat of an interloper attempting to discover it by brute force attack. How much time will it take to break the password? So the solution is 1 by 2x the number of possible passwords into the number of uh, time of enter one password. So the second question is, if the data entry and transmission rate for is t characters per minute, the number of characters involved for entry and replying in a login attempt is I characters, comma, the length of password is x characters and the number of letters and numericals from which the password is selected is n characters. Then the time to break the password will be, the solution is 1 by 2 n raised to the power x into l by t. So let's move to the next question. The sub question of the first. Calculate the expected save time if brute force attack is calculated out by truly working at a keyboard with data entry rate t is to 120 characters per minute. The character set size n equals 20 characters. The password length is 6 characters and the number of characters L in the login is 15 characters. So the solution is 1 by 2 into 20 raised to the power 6 into 5 by 120 minutes. And after calculating this, we will get 7.6 years as our answer. So calculate the expected save time if the exhaustive search is aided by two machines in parallel for the above data. So if two machines are working in parallel, then twice as many password can be cracked in the same amount of time. Therefore, the expected time to crack the password using two machines in parallel would be half the time it would take with only one machine. Expected time with two machines would be 7.6 by 2, that is 3.8 years. Calculate the length of password if the character if 26 characters are used to create a password that will have probability of not greater than 0.001 of being discovered after systematic attack of 1 month. Data entry rate is 300 characters per minute and the login entry required 15 characters. Solution is given by using Anderson formula. So here, 26 raised to the power x should be greater or equals to 4.32 into 10 into 300 into 1, that is to be divided by 15 into 0.001. So here answer would come to be uh, 26 raised to the power x greater than equals to 8.64 into 10 raised to the power 8. So if we put 6 into the place of x, then 26 raised to the power x is should be greater than equals to 3.909 into 10 raised to the power 8. Question number 2. Illustrate the public key implementation of Revest, Shamir, and Alderman with p raised to the p equals to 7, q equals to 11. Solution. Two prime numbers selected are 7 and 11. Then the two numbers n and r are calculated. N is equals to p into q. So n will be equals to 77, and then we'll calculate r, which is equals to p minus 1 into q minus 1. which will be equals to 60. So we will select an integer e where e will be smaller than r and e has no common factors with r. So let's take e equals to 37. Calculate the integer d where ed should be equals to 1 mod r equals to 1 mod p minus 1 q minus 1. So 30d will be equals to 1 mod 60. So d will be equals to 13. The decryption key of the secret key will be 13, 77, and the encryption key, which is the public key, will be 37, 77. Thank you so much. Thanks for watching.